Welcome to the Kentucky Watershed Academy, Module 1, the Clean Water Act and Related Laws. In this presentation, we're going to look at the monitoring and assessment programs. When water quality monitoring in Kentucky first began, it consisted of a statewide network of only 45 sites throughout the entire state. Since the Watershed Management Framework approach was adopted in 1998, the number of monitoring sites has increased and more intensive monitoring has been achieved. The Division of Water's Water Quality Branch is responsible for monitoring and assessing the quality of Kentucky's streams, lakes, and wetlands. Using the data it collects, the branch staff revises water quality standards and criteria, classifies whether or not a water body satisfied its designated uses, and helps develop standards for KPDES permit decisions. Some of the approaches used by the Division of Water to understand and classify Kentucky water bodies are listed here. We'll be reviewing these different approaches to sampling and assessing water quality. After describing these monitoring approaches, we will talk about the National Water Quality Inventory reporting. This combined or integrated report satisfies the Clean Water Act sections 305B and 303D requirements to report to Congress every 2 years. We also explain the ongoing Total Maximum Daily Load reports, or TMDL reports, required from the Division of Water for streams that are found to be impaired. This map shows an overview of all types of state monitoring sites throughout the state, with major river basins shown in different colors. Kentucky uses two monitoring approaches: ambient monitoring at sites consistently sampled to observe general water quality conditions and trends. The ambient program uses streams and rivers and a separate program of lakes. Probabilistic monitoring is the other approach, in which sites are chosen at random to assess the overall health of streams. This is used for a number of reasons. It provides data that can be statistically applied to all waters in a basin of similar type for general assessment purposes. It is inherently unbiased and provides a representative assessment of the actual conditions of water quality in a basin. And it provides comparable data trends of the biological health of each basin. Historically, a basin management framework was utilized to focus on sampling on a rotating basis for both ambient and probabilistic monitoring. Since 2016, the ambient river monitoring has maintained a rotating basin component, but there is no longer a basin rotation component to the probabilistic monitoring. Instead, there is a statewide approach. Probabilistic stream monitoring of macroinvertebrate populations at about 50 randomly selected sites statewide each year is conducted. This type of sampling takes place on boatable, wadable, and headwater streams in order to more broadly characterize aquatic life support for that basin or watershed area. In other words, results are generalized to describe similar stream types within that watershed or basin. There's also probabilistic monitoring of wetlands that assesses amphibians, soils, and other parameters. This map shows the ambient rivers monitoring. The primary fixed stations in blue are sampled every year if possible. The orange color are rotating stations and are sampled during the year of focus for that particular basin management unit. Thus, they should be sampled every 5 years. The rotating basin management unit cycle follows this sequential order. 1. The Kentucky River Basin. 2. The Salt and Licking River Basins. 3. Tennessee and Mississippi and Cumberland River Basins. 4. The Green and Tradewater River Basins. And 5. The Big and Little Sandy and Tigris River Basins in eastern Kentucky. This map shows the locations of all lakes that are sampled through Kentucky's Ambient Lake Monitoring Program. The Division of Water's Water Quality Branch is responsible for this effort. In 1981, Kentucky created a lakes monitoring program that would satisfy the Clean Water Act Section 314 goals to assess all publicly owned lakes in the state. Currently, a total of 108 lakes are sampled, also on the rotating Basin Management Unit approach. The data is primarily used to determine support for aquatic life. Other types of water quality assessments are conducted by division staff. The Reference Reach program began in 1991, where the division also began collecting and summarizing data from least disturbed streams in order to develop an appropriate regional bioassessment criteria. The physical, chemical, and biological analysis of these least impacted streams in a bioregion provides benchmarks for conditions that are naturally attainable in each bioregion. TMDL sampling is necessary to help assess the pollutant concentrations and loading in a stream system so they can accurately report a TMDL budget. More about TMDLs is to come, but it has to do with creating a pollution diet for a stream so that its water quality meets minimum standards. Intensive monitoring is sometimes needed to gain a more in-depth understanding of water quality in specific water body areas of interest or concern. Success monitoring is used to verify that the best management practices are enabling water quality improvements. Ideally, this type of targeted monitoring will demonstrate that management efforts have improved a water body's condition to levels that meet the attainment of its designated uses. This will allow for a 303D delisting, which are noted as a success by the US EPA. Non-point source monitoring techniques are typically used to show whether or not non-point source management approaches are decreasing runoff pollutant contributions. Wetlands monitoring and assessment is also being conducted by the Division of Water to establish a baseline in wetlands extent, condition, and function, and to characterize trends over time. Once these goals are better achieved, the Division of Water plans to develop wetland-specific water quality standards and designated uses. Eastern Kentucky University is assisting with the development of vegetation and amphibian indices for biotic integrity for wetland assessment. Groundwater monitoring is conducted by the Kentucky Division of Water and others such as the Kentucky Geological Survey to assess water quality parameters and note changes or issues. Frequently, monitoring well sites are used to collect samples and dye tracing is used to determine flow paths. As an overview, monitoring data is used to make water quality assessments. These assessments are then used to make decisions about designated use attainment. So how is the monitoring data translated into assessments? Well, one set of criteria for water quality assessment is the basic physical and chemical conditions. This includes parameters with numeric criteria such as temperature, pH, and dissolved oxygen. An assessed water's support categorization is based on the frequency of the samples meeting the criteria. For example, if a stream's dissolved oxygen readings are above the acceptable threshold of 5 milligrams per liter, and at least 90% of the samples taken, it is in full support of the associated aquatic life use for that parameter. Kentucky also has water quality standards for metals concentrations such as iron, lead, and arsenic. These fall under the category of toxic pollutant criteria. In order to fully satisfy designated uses, no violations are allowable with quarterly sampling, and only one sample can exceed the metal standard with a monthly sampling frequency. Kentucky also uses biological assessments for water quality, including evaluations of algae, microinvertebrates, and fish. These assessments incorporate many different observations and factors and results in an index rating of full, partial, or non-support for aquatic life support. To evaluate the safety of water bodies for recreational uses, such as swimming, boating, and fishing, the Division of Water samples both bacteria, E. coli or fecal coliform, and pH levels. For bacteria assessments, samples are collected during the recreational season of May through October, and ideally, 5 samples are collected within a 30-day period. The geometric mean, which is a type of average, helps moderate the wide fluctuations often reserved with bacteria counts. CFU means colony forming units, and it's used as a way to assess E. coli concentrations in the lab. In order to support the primary contact recreation use, water pH should be greater than 6 and less than 9. Otherwise, the water body is considered in non-support of this use. Partially supporting occurs if less than 10% of the samples exceed the normal range. Non-support occurs if more than 10% exceed normal range. Water quality assessments are summarized in a report to Congress, which is required every 2 years. Kentucky now uses a combined or integrated report that includes satisfaction of the 305B requirements to report water quality assessment findings and the 303D requirements to submit a list of water bodies that do not meet associated water quality criteria. The 305B report includes a list of all water bodies that have been assessed for one or more designated uses. Water bodies are put into different categories depending upon the assessment decision made for that water body. This table shows the numeric rating for a variety of assessment categories. Categories 1 through 2C are considered supporting the use. Category 3 indicates that the water body has not been assessed. Categories 4 and 5 are not supporting or impaired. However, only waters in the 5 category are included in the 303D list because waters in the 4A, 4B, and 4C categories are being addressed through a TMDL or other means, or the non-support designation is due to something other than a manageable pollutant source. This table shows the number of assessed segments per category for each of the designated uses. Note the large number of segments in Category 3, meaning that not enough information has been collected to perform these assessments. Note that only 14% of the water bodies in the state have been assessed. This means that the majority of streams in the state have not yet been assessed. Unassessed water bodies are assumed to be fully supporting, but the reality is the percentages are probably similar to what has already been assessed. This is part of the reason behind the probabilistic monitoring that is conducted. Of the 14% of streams that have been assessed, not all designated uses have been assessed fully. Some designated uses are assessed for most streams, such as aquatic life use and primary contact recreation, while others are only conducted for select streams, that is, drinking water use being collected at places in which there is a withdrawal point. For example, in the 2016 report, only 13% of the streams that had been assessed were not assessed for aquatic life, but 95% were not assessed as a drinking water supply. Also, TMDLs were developed much more frequently for primary contact recreation, that's 358 segments, rather than aquatic life use, that's only 21 segments, or fish consumption, in which case only one segment has a TMDL that's been developed. So keep in mind that as more streams are assessed for more uses, we will likely find more impairments throughout the state. This table summarizes the 2016 assessments by the number of stream miles or the percentage of stream miles. Note that the designated use with the greatest number of assessed miles listed as impaired was for aquatic life, but the greatest percentage of assessments leading to a non-support categorization was for primary contact recreation. And this is not surprising because Nonpoint sources and TMDLs tend to target these watersheds and by the nature of their program seek impaired waters. While, all water bodies assessed for drinking water use or domestic water supply, which is a very small number, fully met the criteria for this use. This is a typical map used to display Kentucky's water quality assessments. This map, in particular, shows which water bodies fully support, that's the green color, partially support, in yellow, or do not support, that's red, aquatic life use, based on associated water quality criteria. The different background colors designate the different basins throughout the state. Here's the same type of map, but in this case for primary contact recreation. 41 different causes are associated with the streams and river impairments in the 2016 report. This table summarizes the 10 most common causes, with bacteria and sedimentation or siltation being the top 2 causes by a significant margin. So when a water body is listed as non-supporting of one of its designated uses, a total maximum daily load report is required, or TMDL. The procedure for developing a TMDL includes analysis of water quality data to determine the acceptable pollutant load to the water body, the writing of a document that explains the water quality problem and provides the sampling data to verify it. It also describes the modeling results to help calculate pollutant loading from point and non-point sources and the level of pollutant reductions needed. Finally, it outlines a management process for achieving the necessary pollutant load reductions. A TMDL is sometimes referred to as a pollution diet to help people understand the concept. For this diet, restrictions are recommended from a waste load allocation or WLA portion of the pie. That's the point source contributions. WLA are permitted sources such as wastewater treatment plants, municipal separate stormwater sewer systems or MS4s, combined sewer systems, or other permitted sources. Restrictions are also recommended for reducing load allocation or LA contributions from non-point sources or runoff. These sources could be wildlife or agriculture or other sources. An additional margin of safety or MOS acts as a buffer to ensure that the designated use conditions are met. Illegal point sources, such as sanitary sewer overflows or illicit discharges, are not budgeted in the TMDL because they are illegal. This is not to ignore that these sources do not contribute to the loading of the stream, nor does it mean that a community may not achieve healthy levels by focusing on these sources. It simply means that there is not an allowance in the budget made for these sources. In 2011, the EPA and state TMDL program managers developed a new approach for handling TMDLs. This program vision encourages a range of stakeholder support and agency involvement to help achieve water quality standards through a flexible watershed management approach. In the fall of 2016, the Division of Water submitted TMDL program priorities based on the 2014 303D listings. This pie chart from the 2016 303D report shows how Kentucky stood with regard to these priorities. 223 TMDLs remained due by 2022. 49 public notices for TMDL review were issued in 2018. 41 TMDLs were approved, and 10 alternatives to TMDLs were developed. This is possible when there are available resources that can be more effective at achieving the TMDL goal of achieving water quality support. The TMDL priorities are being updated with findings from the more recent 2016 report. Kentucky's Water Health Portal is a publicly available tool for finding water quality information contained in the 305B and 303D report. Thus, it only contains details for assessed water bodies. Through a mapping interface or search functions for county, water body name, or location info, users can search for the health status of water bodies of interest. Streams are color-coded according to the level of support for its designated uses. When clicked on, a pop-up window shows further details, as well as links to additional information. We've talked a lot in this presentation about the 305B and 303D sections of the Clean Water Act. Now we want to spend a little bit of time focusing on section 319, specifically 319H, which provides non-point source management grants. These grants can be used by the states for education and outreach, demonstration projects, planning, and implementation activities. This graphic provides an overview of the difference between a healthy watershed and an unhealthy one and shows the contributions of various non-point sources. A watershed-based planning process seeks to address all of these sources and recommend ways to better manage land uses for reduced water pollution. This shows the general cyclical process of developing, implementing, and continuously updating and improving a watershed plan. Partnerships are key to getting started. They help build interest and enthusiasm, impart local knowledge during the plan's development, and help with conducting the recommendation implementation activities. The U.S. EPA requires 9 minimum elements for an acceptable watershed plan. EPA-approved plans are currently required to receive 319 funding for watershed implementation or management activities in Kentucky. The 9 minimum elements required by the EPA in a watershed plan, also called the A through I criteria, largely meet steps 2 through 4 of the watershed planning and implementation process. Actually carrying out the plan, making adjustments, and then improving the plan again all follow the establishment of an initial plan. The EPA has its own guidance document for developing watershed plans, but it's lengthy and generalized for the entire country. In 2010, Kentucky published its own Watershed Planning Guidebook, which condensed and simplified the instructions and made it more state-specific. It's available in printed or electronic copies. The electronic version includes many helpful hyperlinks to additional resources. In summary, a 319H approved watershed plan is a flexible framework for managing water quality and quantity. It identifies the causes and sources of impairment and includes strategies to address the most important issues. It also includes an outline for implementation, including the responsible entities, partners, schedule, resources needed, and funding options. And it is required for implementation grant funding subsequent to its completion. This flowchart shows the many aspects of the Clean Water Act, how they're related to one another, and some of the many organizations that are responsible for carrying out portions of the Clean Water Act duties. Obviously, this shows that it's a complicated process, but hopefully we've broken down some of the monitoring, assessment, and listing techniques and give you a better idea how watershed planning incorporates these different aspects and works with these different entities. Thank you for listening in to this presentation.